Okay, so let's talk about jump game. So in this question, you are given an array of non-negative integers numbers. So you are initially positioned at the first index of the array, and each element in the array represents your maximum jump. And just determine if you are able to reach the last index. So in this question, so 2, 3, 1, 1, 4, right? So if I am I index, so I can definitely understand when I reach the second last, I will definitely reach the last index, right? Because the element inside the array are non-negative, right? So if I know I'm at this position, I can definitely know I already reached the last index because I would jump another step, which is definitely reach to the last one, right? So I'm going to know like if I'm at the current position, and I'm going to plus my current index, and I'm going to see if this is greater or equal to the length of the string, length of the array minus one. If that is true, then just return true, and else just return false. So they just code it, and you can actually follow up. And let's see. So I'm going to say int reach equal to 0. So I will start from 0. So I'm going to traverse the loop. And let's see. So I will going to update. So I'm going to update if my current reach is the maximum or the I plus the current number plus my current index is maximum. So in this question, 2 index 0 with my value 2, so the maximum jump is 2, right? And when I equal to 1, um, index 1 plus the value of 1 is 3, so 1 plus 3 is 4, right? So index 2, 2 plus 1 is 3, 3 plus 1 is 4, right? So if we already know the second last index, we don't actually have to um, traverse the entire loop, right? So that would be the whole solution. So if I already know if reach greater equal to my second last, then I can just return true. Else I can return false, right? And that would be the entire solution. And if you also want to know, like, you can actually say that I will less than equal to reach, which means reach is never ever um, before the I index, right? So imagine your reach is right here. Then if you keep adding your I, right? This is not allowed. This is definitely not allowed. Just return false. So you will definitely have initial I and R at index 0. So this is how you actually do it. And you definitely won't, right? So it's non-negative. Non-negative. I mean, it could be 0, but let's just run it and see what happens. So let's see. All right, pass the test. So let's talk about time and space. So for the time, it's actually all of n, right? You traverse every single element inside the array. And for the space, it's pretty much constant, right? You're not using any space. So all of one, all of one for space, all of n for time. So without this, I mean, without I less than equal to n, so let's just run it and see what happens. I mean, this question, you shouldn't have problem, but when you have index 0, I mean value is 0, then that will cause a problem because I is greater than reach, and reach shouldn't be less than I. So that would be the problem, right? So just making sure you know if there's a 0 in the array, it might cause a problem when I is greater than R, and that's not allowed. So otherwise it's pretty good, and this question is pretty standard. It's a little bit hard. Just think about how you actually need to keep counting your uh, current max, exactly current max in the array. So good luck.